Hello students, today we'll discuss the assignment number 1 on limits, and your first question is here. You have to find the value of this limit. So you can say limit x tends to 3 minus x minus 2 upon x minus 3. Yes. Now sir, you can say x is what? X tends to 3 minus, means 3 from the left hand side. So you can say what? You can put x is what? X is 3 minus some h, where h is what? H is some greater than 0, some positive thing. Yes. So this limit is what? This limit is now limit x tends to 3 minus, so it means h tends to where? H tends to 0 plus. Yes. And x is what? 3 minus h, so this thing is 3 minus h minus 2 divided by 3 minus h minus 3. Okay. And this thing is what? This thing is limit h tends to 0 plus limit h tends to 0 plus 3 minus 2 is 1. So 1 minus h divided by 3 minus 3 is, that is 0, and 0 by 0 minus h is minus h. Got it? So this is the thing. Limit h tends to 0 plus 1 minus h upon minus h. Now, sir, whenever h is very close to 0, so numerator is 1 and denominator is negative and tends to 0. So the whole thing is what? Some finite upon 0, that is infinity with the minus sign. So you can say this is what? This tends to where? This is what? This is minus infinity. Okay. So the value of this limit is what? Minus infinity. And this is your final answer. Now, let's do the next one. This is your function and you have to prove that limit does not exist at x is equal to 0. So sir, first of all, let's calculate your left hand limit. Okay. First of all, calculate your left hand limit. So left hand limit is, sir, limit x tends to 0 minus and fx. Yes, fx. That is your left hand limit. Now, sir, limit x tends to 0 minus means smaller than 0. So whenever x is less than 0, so function is what? Function is x minus 1. So that is x minus 1. Got it? And this thing is what? When you put 0 here, you'll get this thing as minus 1. 0 minus 1 is minus 1. Got it? Now find your right hand limit. So RHL is right hand limit. So this thing is what? This thing is, sir, limit x tends to 0 plus and of fx. Yes. So this thing is what? This thing is limit x tends to 0 plus and fx is what? Whenever x is greater than or equal to 0, your function is x plus 1. So you can say this thing is what? This thing is x plus 1 now. Okay. And when you put 0, you will get what? 0 plus 1, which is 1. So clearly you can say left hand limit and right hand limit are not equal. Okay. So from here you can say LHL is not equal to your right hand limit. Okay. So from here you can say limit x tends to 0, limit x tends to 0, fx does not exist. Does not exist. Okay. Limit does not exist at 0. Okay. So this is your question number 2. Now let's do the next one. Next one is here. Third, fx is this function and you have to find that limit of fx x tends to half. If exist, then you have to find this limit. Okay, sir. So sir, first of all, let's find the left hand limit. Okay, left hand limit. So left hand limit is left hand limit. Left hand limit is limit x tends to half minus x tends to half minus fx. Okay. So now we have two situations. Whenever x approaches half from the left hand side, so this number may be what? This number may be rational or may be irrational. Yes. So you have two cases. You have two cases. Okay. So first one, limit extends to half minus, limit extends to half minus fx. Whenever this number is what? Rational. So rational, then value is what? Your function is x. So this is x. So you can say this limit is what? This limit is half. Okay. Similarly, whenever limit x tends to half minus and your x is what? Irrational, then your function is 1 minus x. So you can say that is 1 minus x. So this limit is what? This limit is 1 minus half, that is half again. Okay. So in both the cases, you can say your limit is what? Limit x tends to half minus half. From the left hand side, you can say that is half. Okay. So this thing is what? This thing is half. LHL is half. Got it? Now next one is what? Next is right hand limit. So now let's calculate your right hand limit. So right hand limit is, that is limit x tends to half plus limit x tends to half plus fx. Okay. So again you have two cases. When x approaches half from the right hand side, so either x is rational or irrational. So you can say limit x tends to half plus f of x. Whenever x is rational, so fx is x. So you can say this thing is half. Okay. Next one is limit x tends to half plus f of x, and if x is irrational, then value is 1 minus x. 1 minus x. So this is what? This is 1 minus half, that is again half. Okay. So from both the cases, you can say right hand limit is half. Okay. And here your left hand limit is half. So you can say left hand limit is equal to right hand limit is equal to half. So you can say limit of your function exists, limit of fx exists at x is equal to half. Yes. And this thing is what? This thing is equal to 1 by 2. Okay. Limit extends to 1 by 2. Fx is what? That is 1 by 2. So this is your final answer for question number 3. And that is what? That is the important one. Okay. Important one. Got it? Now let's do the next one. Next one is here. Evaluate the left hand and right hand limits of the function. Okay, sir. No problem. So, sir, left hand limit is left hand limit. That is left hand limit is limit extends to 4 minus. Yes. You have to find what? You have to find the limit at x is equal to 4. So at x is equal to 4, you can say left hand limit is what? Limit x tends to 4 minus, yes, that is fx. So whenever x is not equal to 4, means x tends to 4. So this is not 4. So you can say function is what? Function is mod x minus 4 divided by x minus 4. Okay. So you can say this is limit x tends to 4 minus, limit x tends to 4 minus. So whenever x is 4 minus, means x approaches 4 from the left hand side. So this thing is what? This thing is negative. For example, 3.999 and so on, minus 4. So that is a negative quantity. So modulus of negative opens with the negative sign. So you can say this is minus time x minus 4 divided by x minus 4 already in the denominator. So you can say this is what? This is minus 1. Yes, you can cancel x minus 4 with x minus 4. So remaining thing is minus 1. Got it? Now, so right hand limit is limit extends to 4 plus mod of x minus 4 divided by x minus 4. Yes, mod x minus 4 upon x minus 4. So this thing is what? This thing is limit extends to 4 plus. Now mod x minus 4 opens with what? Positive sign. So this is x minus 4 upon x minus 4. And this thing is what? This thing is 1. So left hand limit is minus 1, right hand limit is 1. So both are not equal to each other. So you can say, okay, here you have to find the left hand and right hand limit. Okay. So minus 1 and 1. Or if you have to find the limit, so limit does not exist here. Okay. So that's the final one. Now let's do the next one. Next question is here. So sir, situation is You have a function fx and gx. You have functions fx and gx, and find the left hand and right hand limit of this function at x is equal to 0. Hence find limit x tends to 0 g of fx. Okay, sir. So left hand limit. First of all, calculate the left hand limit of this. So left hand limit at x is equal to 0 is what? Sir, means x tends to 0. Yes, for the left hand limit, so you can say x tends to where? X tends to 0 minus. Yes, we are calculating what? We are calculating the left hand limit. Okay, we are calculating what? The left hand limit of this function at x is equal to 0. So you can say x tends to 0 minus for the left hand limit. Yes. And sir, you want f0 minus now. Okay, f0 minus. Yes or no? You want f0 minus. So whenever x tends to 0 minus, so x is what? X is negative. So whenever x is negative, less than equal to 0, so function fx is what? 2 minus x. So you can say this tends to where? 2 minus x. Yes. And sir, x is what? X is 0 minus, means negative. So negative, negative, positive. So this tends to what? This tends to 2 plus. Yes or no? Okay. So you can say g of f 2 plus now. Oh, sorry. F 0 minus. Yes. G of f 0 minus. So f0 minus tends to 2 plus. So this is what? This is g of 2 plus. And this thing is what? G of 2 plus is, so 2 plus greater than or equal to 2. Gx whenever x greater than or equal to 2, that is x minus 5. So you can say this thing is 2 minus 5. Yes, 2 minus 5, which is what? Which is minus 3. Okay, so you can say left hand limit of g f x at x is equal to 0 is minus 3. Similarly, you can calculate what? Right hand limit. So right hand limit is x tends to 0 plus. So from here f0 plus tends to where? F0 plus tends to f0 plus greater than 0, that is 0 plus 1 means 1 plus. Yes, that tends to 1 plus. Got it? Now g of f0 plus right hand limit, that is what? That tends to g of f0 plus is 1 plus, that is 1 plus. And this thing is what? 1 plus whenever x is 1 to 2, then gx is x square minus 2x minus 2. So this thing tends to 1 square minus 2 into 1 minus 2, which is equal to what? Which is equal to 1 minus 2 minus 2, that is minus 3. Got it? So left hand limit and right hand limit both are minus 3. So you can say limit of this function exists, limit of g of fx at x is equal to 0 exist. Yes, at x is equal to 0 exist and equal to minus 3. Okay, so this is what? This is the final answer. Got it? So again, important one. So this is your question number 5. Answer is minus 3 here. Now let's do the next one. Next is here. So what is the question? Question is, sir, fx is this and find the value of a so that limit of fx exists at x is equal to 0, where this denotes the greatest integer function. Yes, less than or equal to x. Got it? Now sir, we already know that limit of function exists at x is equal to 0. So you know left hand limit is equal to right hand limit. So first of all, calculate your left hand limit. Okay, left hand limit. Left hand limit is what? That is limit x tends to 0 minus fx. Limit x tends to 0 minus fx. And this is limit x tends to 0 minus. 0 minus means x less than 0. So your function is what? Mod x plus a. So you can say that thing is mod x plus a. Okay. So now this thing is what? 0 minus, so this is 0 plus a, that thing is a. Clear? Now similarly you can find what? You can find the right hand limits. Yes, right hand limit is what? Right hand limit is limit x tends to 0 plus f of x, which is equal to what? Which is limit x tends to 0 plus, and this thing is cos of greatest integer x, cos of greatest integer x. Yes, cos of greatest integer x. So cos of greatest integer x, and this thing is 0 plus. So whenever x tends to 0 plus, so greatest integer x is 0. So this thing is cos 0, cos 0, and cos 0 is what? 1. Got it? Now you know limit exists, so it means left hand limit and right hand limit are equal. So from here you can say a is equal to what? A is equal to 1. Okay, so this is what? This is the final answer for your given question. The value of a is 1. Got it? Now let's do the next one. Next one is here. You have to show that limit does not exist for this function. Okay, so first of all calculate your right hand limit. Okay, let's calculate the right hand limit. Okay, so right hand limit is limit x tends to 0 plus, that is e power 1 by x minus 1 upon e power 1 by x plus 1. Okay, now you can take e power 1 by x common. So this thing is limit x tends to 0 plus, yes, 0 plus, that is e power 1 by x common. So this thing is 1 minus e power minus 1 by x divided by e power 1 by x common 1 plus e power minus 1 by x. Yes or no? So you can cancel what? You can cancel e power 1 by x with e power 1 by x. So you left with limit x tends to 0 plus, yes, x tends to 0 plus, that is 1 minus, this thing is what? This thing is 1 minus e power minus 1 by x divided by 1 plus e power minus 1 by x. Yes, 1 minus e power minus 1 by x, 1 plus e power minus 1 by x. Now sir, x tends to 0 plus. So 1 upon 0 plus is plus infinity. Okay, and you have minus sign already here. So that thing is what? That thing is minus 1. Yes, that thing is minus 1 by 0 plus. So that is minus infinity. Okay, so this thing is what? This thing is minus infinity. E power minus infinity. And e power minus infinity is what? That tends to 0, if you remember. Yes, e power minus infinity tends to 0. So this thing tends to 0. This thing tends to 0. So your limit is what? Limit is, your limit is what? Limit is 1 minus 0 upon 1 plus 0. 1 minus 0 upon 1 plus 0, which is equal to 1. Okay. So right hand limit is what? 1. Now calculate your left hand limit. Your left hand limit. So left hand limit is what? That is limit x tends to 0 minus, limit x tends to 0 minus, okay, f of x, that is e power 1 by x, e power 1 by x minus 1 upon e power 1 by x plus 1. Got it? So now sir, it's clear now. So x tends to 0 minus. So 1 by x is what? 1 by x tends to minus infinity. And e power minus infinity tends to 0. This tends to 0. So this limit is what? This limit is 0 minus 1 upon 0 plus 1, which is equal to minus 1. Okay. So left hand limit is minus 1. Right hand limit is 1. So you can say limit, left hand limit, you can say from here you can say left hand limit is not equal to right hand limit. Yes, left hand limit is not equal to your right hand limit, Okay, so from here you can say limit of limit of e power 1 by x, limit of e power 1 by x minus 1 upon e power 1 by x plus 1, e power 1 by x plus 1, x tends to 0, x tends to 0 does not exist, does not exist, DNE does not exist. Okay, so that's the proof for the question number 7. Now let's do the next one. Next is here, evaluate the limit. Okay, so calculate your left hand limit first of all. So left hand limit is, that is limit x tends to 0 minus, so this one is 3x plus 3x and this plus mod x. Okay, mod x, now x is what, x is 0 minus means negative, so mod open with negative sign, so this is 3x minus x divided by 7x minus 5 into minus x. Yes, so this thing is what, this thing is limit x tends to 0 minus 3x minus x, that is 2x divided by 7x plus 5x, that is 12x. Now you can cancel x by x. Yes, you can cancel x by x. 12 by 2 you will get 6. So this limit is what? This limit is 1 by 6. Got it? Now calculate right hand limit. So right hand limit is limit x tends to 0 plus, okay, that is 3x and mod open with the plus sign now because x is positive, so 3x plus x divided by 7x minus 5 into x. Okay, so from here you can say limit x tends to 0 plus, and this thing is 4x by 2x, 4x by 2x. So clearly this is what, this is 2. Yes, you can cancel x by x, 4 by 2 you will get 2. So final limit is what? Final is 2. So here you can say LHL is 1 by 6, RHL is 2. So from here we can conclude left hand limit is not equal to right hand limit. So from here we can say limit x tends to 0, limit x tends to 0, 3x plus mod x, 3x plus mod x divided by 7x minus 5 mod x, 7x minus 5 mod x. Yes, does not exist, does not exist, that limit does not exist. Okay, so that's the answer for question number 8. Now let's do the next one. Next is here. Okay, so that's simple one, that's the graph, and you have to consider the following graph of your function. Which of the following is correct, is or are correct? Okay, so first one is limit x tends to 1, fx does not exist. So whenever x is approaching 1 from the left hand side, so your function is very close to 2. Yes, whenever you are here, whenever x is very close to 1 from the left hand side, so your function is where? Function is somewhere here, very close to this point, and this is what? This is y is equal to 2. Okay, so you can say left hand limit, here the left hand limit is what? Left hand limit is 2. Yes, and what is right hand limit? So what is right hand limit? Right hand limit is what? Right hand limit whenever x is very close to 1 from the right hand side, so that fx is where? Fx is somewhere here, that is very close to 3. Yes, very close to 3. So you can say right hand limit is what? Right hand limit is 3. Are they equal? No. So limit does not exist. So this is what? This is the correct answer, correct option. Yes, fx, limit of fx whenever x is 1 does not exist. Yes, LHL and RHL both are different. So you can say this is the correct one. Okay, next B is what? Limit x tends to 2, fx does not exist. Okay, let's observe. X tends to 2. x tends to 2. So LHL gives you, LHL is here. Yes. So your function is very close to 3. RHL is what? RHL is also 3. Yes, LHL and RHL both are what? Both are 3. So you can see here LHL is equal to RHL, both are equal and both are equal to 3. So limit exists. So limit extends to 2. So limit extends to 2, fx exists. Okay, hence limit extends to 2, fx exists. Okay, but your option is does not exist, so it means this is not the correct. Okay, now for this one, limit extends to 3 fx. So clearly limit extends to 3 fx, that is what? That is very close to 3, very close to 3. So you can say here left hand limit and right hand limit both are 3. Left hand limit is equal to right hand limit is equal to 3. So you can say limit of your function exists at 3, and that thing is what? 3. So this is the correct one. Got it? Now 1.99. 1.99. So sir, clearly 1.99 is very close to here. So whenever you are approaching 1.99 from the left or right, so your function approaches what? Your function approaches the same number 3. Okay, so you can say here left hand limit is equal to right hand limit. Okay, left hand limit and right hand limit whenever x is 1.99, that is what? That is 3. Okay, so left hand limit and right hand limit both are what? Both are 3. So you can say limit of your function exists whenever x is 1.99. So this is also the correct one. Okay, so you have to choose the correct options. So A, C and D, these are what? These are the final one. Okay, A, C and D. Okay, A, C and D, this is your final answer. Clear? Now let's do the next one. Next is here, if limit of this is 2 and limit of this is 1, then find the value of this thing. So sir, we know if limit of some function exists and limit of another function exists at same point, so limit of their sum also exists and limit of their difference also exists. So sir, you can say from here we can say limit extends to a fx plus gx plus fx minus gx. Yes, got it? Or you can say in more appropriate way, you want what? You want fx into gx. So let's calculate limit of limit x tends to a fx. So you can say this can be written as limit x tends to a fx is what? Fx can be written as 1 by 2 into fx plus gx plus fx minus gx. Okay, limit extends to a half fx plus gx plus fx minus gx. Yes, now you can cancel gx with gx. Fx plus fx is 2fx, so 2 cancels with 2, so this is fx. Yes, and this thing is what? This thing is, you can take half common. Okay, and this thing is limit extends to a fx plus gx plus limit extends to a fx minus gx. Yes, fx minus gx. Yes, limit of this function and limit of this function. Okay, fx plus gx and fx minus gx. Now you know, this thing is what? This thing is half into limit x tends to a, fx plus gx is what? That is 2. Plus limit x tends to a, fx minus gx, that is 1. So this thing is what? This thing is 3 by 2. So limit of fx whenever x tends to a, that is 3 by 2. Similarly, you can calculate limit x tends to a, limit x tends to a, g of x. That thing is limit x tends to a, half fx plus gx minus fx minus gx. Yes, fx plus gx minus fx, and this is plus gx minus fx, fx cancel. This is 2gx, 2 cancels with 2, so this is gx. Yes, so this thing is what? This thing is half. Yes, now you can say this is limit x tends to a. Yes, limit x tends to a, fx plus gx and plus minus limit x tends to a, fx minus gx. Yes, fx minus gx. Got it? So this thing is what? This thing is half into this thing is what? That is 2 minus 1. 2 minus 1. Yes, 2 minus 1. So which is 1? 1 into half is half. Clear? So now limit of fx and limit of gx is half at x is equal to a. Now you have to find the value of limit fx gx. Now limit fx into gx whenever x is a. Okay, limit fx into gx whenever x is a. So this thing is what? This thing is, you can say, equal to limit x tends to a, fx into limit x tends to a, gx, and which is 3 by 2 into 1 by 2. Yes, 3 by 2 into 1 by 2, which is equal to 3 by 4. Okay, so answer is 3 by 4. That's the limit of this function. Got it? So limit x tends to a, fx gx is 3 by 4. That's the correct one. Okay, correct answer. Clear? Now let's do the next one. Okay, and this is what? This is your single correct multiple choice question. Okay, which of the following limit exists finitely? Okay, sir. So first one is limit x tends to 0 plus x log x to the base e. Okay, so a part is limit x tends to 0 plus limit x tends to 0 plus x to the power log x to the base e. Okay, sir. So if you observe, this is what? This is, sir, 0 plus. Okay, that thing is 0 plus. Okay, this thing is what? This thing is, you can say, 0 plus. This is 0 plus to the power log x to the base e. Log x to the base e means, so log x to the base e means ln x, and whenever x tends to 0 plus, so ln x is what? Ln x tends to minus infinity. Minus infinity. So this thing is what? This thing is 0 power minus infinity. So you can say 1 by 0 plus to the power infinity. Okay, this means 0 plus to the power minus infinity. Now 0 plus to the power infinity is what? That tends to 0, and 1 upon 0 is what? 1 upon 0 tends to, this is plus 0. Yes, 1 by plus 0, that tends to plus infinity. Okay, so limit does not exist, means limit is not finite here, you can say. That is what? That is infinity. So in this case your limit is not finite, so this is not the correct answer. Got it? Now let's do the next one, b. So b is what? B, so b is limit x tends to 3. B is, for the b part, limit x tends to 3 limit x tends to 3. Sir, x square minus 9 minus x square minus 9 minus, that is under root x square minus 6x plus 9. And this thing is what? This thing is x minus 3 whole square. This thing is x minus 3 whole square. So you can say under root of x minus 3 whole square is mod x minus 3. So that thing is what? That thing is mod x minus 3. Okay. Divided by. This thing is mod x minus 1. So mod x minus 1 whenever x tends to 3. So that is positive. So mod opens with positive sign. So you can say x minus 1 minus 2. So denominator is x minus 1 minus 2. Clear? So first of all, if you observe your function here, so you can say this thing is limit x tends to 3. Limit x tends to 3. And this thing is x square minus 9. So you can say x minus 3 into x plus 3, that is x square minus 9 minus mod x plus 3 divided by x minus 1 minus 2, that is x minus 3. Okay, x minus 3. Got it? So from here you can calculate right hand limit and left hand limit. So right hand limit is limit x tends to 3 plus, that is, sorry, this is mod x minus 3. Yes, this is mod x minus 3. This is mod x minus 3. Yes, that is mod x minus 3. Got it? So sir, now RHL limit x tends to 3 plus. So you can say this is x minus 3, x plus 3 minus, mod opens with what? Plus sign. So x minus 3 divided by x minus 3. Okay. So now you can cancel x minus 3. You will get what? You will get x plus 3. Limit x tends to 3 plus. Limit x tends to 3 plus. So you can say x minus 3. That is x plus 3. X plus 3 minus 1. Okay. So this thing is what? This thing is limit x tends to 3 plus, and this is x plus 3 minus 1, x plus 2. X plus 2, yes, x plus 2, and whenever 3, so this thing is 3 plus 2, which is 5. Got it? So right hand limit is 5. Now left hand limit is limit x tends to 3 minus. So this thing is x minus 3 into x plus 3. So modulus opens with minus sign. So minus minus plus x minus 3 divided by x minus 3. So when you simplify, you will get limit x tends to 3 minus. Okay, limit x tends to 3 minus. You can cancel x minus 3, you will get x plus 3 plus 1. X plus 3 plus 1. So when you put 3 here, you will get what? That is 3 plus 3, 6 plus 1, that is 7. So here LHL and RHL both are distinct. Okay, so from here you can say LHL is not equal to your right hand limit. So from here you can say limit does not exist. Yes, limit of your given function, okay, limit of your given function whenever x tends to 3 does not exist. Okay, so sir, B is not the correct one. Yes, now let's observe the C part. C part is, that is, sir, limit x tends to 1 plus, and this one denotes greatest integer function. Okay, limit x tends to 1 plus, limit x tends to 1 plus greatest integer x. Okay, and this to the power 1 upon x minus 1. Okay, 1 upon x minus 1. Okay, sir, 1 upon x minus 1. So this one is what? This one is limit extends to 1 plus and greatest integer of this, so that is 1. Yes, so this is 1. Okay, to the power 1 upon 1 plus minus 1. 1 plus minus 1 is, that is 0 plus. Okay, 1 by 0 plus is tends to infinity, and 1 power, that is exact 1. So 1 power anything, that gives you 1. Okay, you can say that thing is not tends to 1, this is exactly 1. So exactly 1 to power tends to infinity, that is 1 into 1 into 1 into 1 infinite times, that is 1. Okay, this is exactly 1, that's important thing. Okay, otherwise you have one indeterminate form, that is 1 power infinity, but here that one is exact 1, so 1 power infinity, that is what? 1. Okay, so you can say limit extends to 1 plus greatest integer x 1 by x minus 1, that thing is what? That thing is 1. Okay, so this limit is what? This limit is finite, so option C is what? Option C is the correct option. Got it? Now let's do the next one. 12th question here. Again important one, again important. Sir, set of all values of x such that this limit is non-zero and finite number whenever n belongs to natural number. Okay, sir. Sir, if this thing is what? If this thing, this one, if this thing is, sir, greater than 1, greater than 1, and power is what? 4n, n tends to infinity, so that tends to infinity. And if this is greater than 1, so greater than 1 to the power infinity is infinity. So 1 plus infinity is infinity, and 1 upon infinity tends to 0. So it means your limit is 0. Okay, so it means this cannot be, this cannot belongs to, this thing cannot belongs to where? Greater than 1, means 1 to infinity. Yes, that thing does not belong to 1 to infinity. Yes or no? Got it? No problem. Because if this is 1 to infinity, then the whole thing is infinity, and this limit is what? That is 0. But we are given with that limit is non-zero and finite. Okay, sir, no issue. And similarly, sir, power is 4. So your this thing, this expression does not belongs to here also. Minus infinity to minus 1. Okay, because it belongs to minus infinity to minus 1, so power 4 becomes so it's power 4. Yes, we have its power 4, so that will become what? That will become positive, and then greater than 1, and power is infinity, so number which is greater than 1, power is infinity, so it means that tends to infinity, whole limit is 0, but we are given with non-zero. So sir, this expression does not belong to here. So it means what? So this expression belongs to minus 1 to 1. This expression belongs to minus 1 to 1. Okay, and if this belongs to minus 1 to 1, if not exactly 1, so then this thing is what? This thing is 0. So 1 by 1 is 1. Limit is finite and non-zero. And if this limit is exactly 1 or minus 1, this thing is what? This thing is 1. Okay, 1 plus 1 is 2, then this is 1 by 2, so limit is finite. So clearly we can say from here, sir, 4 tan inverse. From here we can say 4 tan inverse 2 pi x by pi. 2 pi x by pi. Okay, that belongs to minus 1 to 1. Got it? Now multiply by pi by 4. Pi by 4 is positive number, so inequality remains same. So this will become minus pi by 4 less than equal to tan inverse 2 pi x less than equal to pi by 4. Yes. Now taking what? Now taking tan on both sides, you will get what? Tan of minus pi by 4. So from here you can say tan of minus pi by 4 less than equal to tan of, because tan is increasing function. Okay, that's why this inequality remains same. Got it? Tan pi by 4 and this thing. Now tan minus pi by 4 is minus 1. Tan of tan inverse is x, that is 2 pi x. Tan pi by 4 is 1. Now divide by 2 pi on both sides, you will get minus 1 by 2 pi less than equal to, that is x. Okay, that is x, and less than equal to 1 by 2 pi. So from here you can say x belongs to close minus 1 by 2 pi to 1 by 2 pi close. Okay, minus 1 by 2 pi to 1 by 2 pi close. So this is what, this is your final answer. So which option is the correct option? So minus 1 by 2 pi to 1 by 2 pi. Yes. So option C is the correct one. Got it? So option C is what? Option C is the correct answer. Now let's do the next one. Next one is here. So let L1 is equal to this and L2 is this. Which of the following is true? Okay, no problem. So sir, for this one, L1. L1 is limit extends to 4, x minus 6 to the power x, x minus 6 to the power x. Yes, x minus 6 to the power x. Okay, sir. Now if you observe, whenever this x tends to 4, this base is what? This base is negative. That thing is what? That thing is negative. Yes, and this thing tends to what? This thing tends to uh, minus 2. Yes, 4 minus 6, that minus 2. So minus 2 to the power x. And we know this is exponential function a power x. In a power x, a must be greater than 0. But here that is negative. So this thing is does not exist. Yes, this thing does not exist. Does not exist. Got it? L1 does not exist. Now what about L2? L2. L2 is what? L2 is limit extends to 4. Limit extends to 4. X minus 6 to the power 4. X minus 6 to the power 4. So this time, this is what this is. Sir, 4 minus 6 is direct substitution, minus 2. Yes. 4 minus 6, that is minus 2. 4 minus 6 minus 2 to the power 4. So this thing is what? Minus 2 into minus 2 into minus 2 into minus 2. So that is plus 16. Yes. That thing is plus 16. So limit exists here. Yes. So sir, L1 does not exist, but L2 exists. L2 exists. So option D is the correct option. Got it? Next one. Next one is here. Limit extends to infinity and this function. Okay. So limit extends to infinity. Limit extends to infinity. This is x minus log. Now you can take e power x common. So that will be e power x into 1 plus e power minus 2x whole divided by 2. Okay. X minus log. Now you can take e power x common. So this is 1 plus e power minus 2x whole divided by 2. Yes. So, and yeah, log this thing whole divided by 2. Yeah, this expression. Clear? Now This is limit of this function, yes, this whole function. Now sir, you know log m into n is what? Log m plus log n. Okay, log m into n is log m plus log n. So you can say this limit is what? This limit is limit extends to infinity, x minus, this thing is what? X minus log e to the power x. Yes, base is what? Base is e here. So you can say m into n. So this is log m log e to the power x to the base e plus log 1 plus e power minus 2x, 1 plus e power minus 2x whole divided by 2 to the base e. Okay, that's the thing. Now sir, this limit is what? This is limit extends to infinity, e power x, log e power x to the base e, that is x. Yes, this thing is x. So you can say we have x minus log 1 plus e power minus 2x whole divided by 2 to the base e. Okay, so you can cancel x with x. So when you put x tends to infinity, so you'll get what? Limit x tends to infinity minus log 1 plus e power minus 2x, 1 plus e power minus 2x whole divided by 2 to the base e. Yes, now sir, x tends to where? X tends to infinity. So e power minus infinity, is what? That tends to 0. So this is 1 plus 0 by 2, that is 1 by 2. So you can see this limit is what? This limit is minus log 1 by 2 to the base e, 1 by 2 to the base e. So you can say this is what? This is, you can take power minus here. So you will get what? Log half power minus 1 to the base e. Yes, and half power minus 1 is 2. So this thing is what? This thing is log 2 to the base e. Log 2 to the base e. That's the final answer. Log 2 to the base e. So option C is the correct one. Got it? Now let's do the next one. Next is here. Sir, limit x tends to infinity, this one, where this bracket, curly bracket, denotes the fractional part of x is equal to what? Okay, sir. So limit x tends to infinity. You are calculating limit x tends to infinity. So you can say this is a fractional part function, and you can take pi common. Yes, pi power x common. So this will be pi power x common. Yes, pi power x into 1 plus e by pi to the power x and whole to the power 1 by x. Yes, whole to the power, this is pi power x common. So this thing is 1 plus e by pi to the power x. Yes, and whole to the power what? Whole to the power 1 by x. Fractional part function. Got it? Now sir, this thing is equal to limit x tends to infinity, fractional part function. Now pi x to the power 1 by x. So this is pi, yes, into 1 plus, that is 1 plus e by pi, 1 plus e by pi to the power x, 1 plus e by pi to the power x whole to the power 1 by x. Yes, fractional part. Clear? Now, sir, x tends to infinity. Okay, x tends to infinity. And sir, e by pi is what? E is 2.718, approximate value. Approximate. And pi is approximate 3.14. So, e by pi, that is what? That tends to, you can say, e by pi power x, that is what, e power pi is less than 1 and x tends to infinity. E by pi lies between 0 to 1 and 0 to 1 to the power infinity, that tends to 0. So this thing tends to 0. This whole thing tends to 0. Okay. And 1 by x is what? 1 by x also tends to 0. 1 by x also tends to 0. Got it? So sir, this is pi into 1 plus, that is 0 to the power 0. So 1 plus something 0 to the power 0 is, whole thing is 1. Yes, this whole thing is what? This whole thing is 1. This whole thing is 1. So you can say this thing is limit x tends to infinity, and this one is pi into 1, that is fractional part of pi. So fractional part of pi is what? That is pi minus greatest integer of pi. Pi minus greatest integer of pi. That is what? That is greatest integer. Greatest integer function. Okay. So fractional is what? Fractional is that value. Yes, that value minus the greatest integer of that value. So this thing is what? This thing is pi minus, and greatest integer of 3.14 approximately, that is 3. So pi minus 3. So this limit extends to infinity and the whole thing is what? Pi minus 3. So that's the correct one. Means option B is the correct answer. Okay. So this is your question number 15. Now this is our next question and this is from your revision portion. Okay, so question is, you have real valued function fx satisfies some rule here, and where a is what? A is some given constant and f0 is equal to 1. So you have to find what? You have to find that f of 2a minus x is what? F of 2a minus x. Okay, so your given rule is that is f of x minus y. You know, f of x minus y is equal to f of x into f of y, f of x into f of y, yes, minus f of a minus x minus f of a minus x, yes, into f of a plus y, f of a plus y. Got it? F of a plus y. Now, if you put x is equal to a here, x is equal to a, you want what? F of 2a minus x. Yes, f of 2a minus x. So you can put x is equal to a. Yes, x is equal to what? X is equal to a, and y is equal to what? Y is equal to x minus a. Y is equal to x minus a. So put x is equal to a, y is equal to x minus a. So this thing is what? Left hand side is f of, that thing is a minus x plus a, that is 2a minus x. Clear? And which this is equal to what? This is equal to f of a into f of x minus a. Okay, minus f of a minus x. X is a now, so a minus a is 0, f0 into f of a plus y. A plus y is x. Yes, so this is f of x. Clear? Now sir, f0 we already know, that is 1. Now just calculate f of a first of all. So how can you find f of a? F of a. So we can find f of a like this. Put x is equal to y is equal to what? That is 0. Got it? X is equal to y is equal to 0. Okay. So if you put x is equal to 0 here, okay, if you put x is equal to y is equal to what? Y is equal to 0. Put here. In your functional rule, put x, y both as 0. So you'll get what? You'll get f of 0 minus 0 is f0. So that is f0 is equal to what? Is equal to f0 into f0. That is f0 square. Okay, f0 square minus f of a minus 0 is fa, f of a plus 0 is fa, that is minus fa square, minus fa square. Now sir, now clearly we know f0 is what? f0 is 1. So this thing is 1 is equal to 1 square is 1 minus f of a square, f of a whole square. So when you calculate the thing here, you will get what? F of a is equal to what? F of a square is equal to f of a square is equal to 0. Yes, 1 is equal to 1 minus this, and if you cancel 1 by 1, you will get f a square is equal to 0. So if f a square is equal to 0, so it means f of a is equal to 0. Got it? So you can use that information here. F a is 0. So the whole expression is 0. F0 is 1. So clearly f of 2a minus x is equal to 0 minus 1 into fx, that is minus fx, minus time of fx. Okay, f of 2a minus x is minus fx. So final answer is B here. Okay, the correct option is B. Got it? Now let's do the next one. Next is here, you have some relation here on the set A, where set A is 1, 2, 3, 4. You have to tell me the relation R is what? So if you observe, sir, you have 1, 3 here, you have 3, 1. 4, 2, you have 2, 4. But here you have 2, 3, but 3, 2 is not in your relation. Yes? So you can say 2, 3 belongs to R. 2, 3, that belongs to where? That belongs to the relation. Yes? But 3 comma 2 is not the member of your relation. Yes, 2 comma 3 is here. 2 comma 3 belongs to a relation, but 3 comma 2 does not belongs to a relation. Yes, 3 comma 2 is not here. So you can say AB belongs to R, but BA does not belongs to R. For every AB belongs to A, so it means relation is not symmetric. Okay, so you can say from here you can conclude R is not symmetric. Yes, so you can say relation is not symmetric relation. So option A is the correct one, not symmetric. So option A is the final answer. Got it? Now let's do the next one. Next is here, the range of the function fx is what? You have to find the range. So first of all, you have some conditions here. First is 7 minus x. Okay, 7 minus x must be greater than, or you can say equal to 0. So from here you can say x is less than equal to 7. Okay, first condition. Next one is what? Next one is, sir, x minus 3. X minus 3. That must be what? That must be greater than or equal to 0. Okay, so from here you can say x is what? X is greater than equal to 3. Got it? X must be greater than equal to 3. That's the second condition, because NPR is defined whenever n greater than 0, r greater than equal to 0, and n is greater than equal to r. And the third condition is what? Third condition is 7 minus x must be greater than or equal to x minus 3. So when you simplify it, you will get what? You can take x on that side. So you will get 2x less than equal to 7 plus 3, which is 10. So from here you can say x is less than equal to 5. X is less than equal to 5. So you have to satisfy all the conditions simultaneously. So you have to take what? You have to take the intersection of this. So x is what? X belongs to greater than equal to 3, less than equal to 7, or less than equal to 5. So intersection is 3 to 5 close. Got it? 3 to 5 close. And 7 minus x must be an integer. So you can say x must be an integer. And if x is an integer, so possible values of x. Possible values of x are 3, 4 and 5. 3, 4 and 5. Yes. So your range is what? Range contain 7 minus 3. So possible values of your function is 7 minus 3 p 3 minus 3. Yes, 7 minus 3 p 3 minus 3, which is equal to 7 minus 3 is 4 and p 3 minus 3 is 0. Okay, so 4p is 0. That is 4p 0, which is 4 factorial. NPR is what? N factorial divided by n minus r factorial. So that is 4 factorial divided by 4 minus 0 factorial, that is again 4 factorial. So this thing is what? This thing is 1. Now next is, whenever x is 4, so 7 minus 4 p 4 minus 3. That is what? That is 7 minus 4 is 3 p and 4 minus 3 is 1. 3p1 is what? 3 factorial upon 2 factorial, which is 3. Okay, and the last one is whenever x is 5, so thing is what? The thing is 7 minus 5 p 5 minus 3. Yes, 5 minus 3. So you can say this is 2p2. 2p 5 minus 3 is 2. So you can say 2 factorial upon 0 factorial, that is 2 upon 1, which is 2. Yes, so possible values of your function are 1, 3 and 2. So you can say range is what? Range is 1, 2 and 3. So 1, 2, 3. Set 1, 2, 3. So option C is the correct option. Okay. Now let's do the next one. Next is here. And you have to find what? You have to find. You have, so first of all, you have some function from R to S. Okay. Defined like this is onto. Onto means what? Onto function means your range and codomain both are same. Then the interval of S is what? You have to find S, means you have to find if function is onto, so this codomain is equal to the range, so you have to find the range of this function. Okay, so how can we find this range? So sir, you can say sin x minus root 3 cos x. Sin x minus root 3 cos x always greater than or equal to minus time under root over 1 square plus minus of root 3 square. Yes, and this thing is less than equal to under root over 1 square plus minus root 3 square. Got it? We already know one thing, that is a sin theta plus b cos theta. A sin theta plus b cos theta always lies between minus under root a square plus b square to under root a square plus b square. Okay, a is 1 here, b is minus root 3. So 1 square plus minus root 3 square, and similarly here. So this thing is what? 1 plus 3, that is 4. Under root of 4 is 2. So you can say minus 2 from here. You can say minus 2 less than equal to sin x minus root 3 cos x less than equal to 2. Okay, now add 1 on all sides. You can say this is what? Minus 2 plus 1, that is minus 1 less than equal to sin x minus root 3 cos x plus 1 less than equal to 3. And sin x minus root 3 cos x plus 1 is what? Sin x minus root 3 cos x plus 1 is your function. So from here you can say minus 1 is less than equal to your function, and function is less than equal to 3. So you can say fx lies between minus 1 to 3. So this is what? This is the range of your function, and function is on 2. So range is equal to the codomain, which is S. So S set is what? S set is minus 1, 2, 3 close. So minus 1, 2, 3 close, that is option D. Okay. So D is what? D is the correct answer. Got it? Now let's do the next one, and this is the last question of your assignment. Question is, the graph of the function is symmetric about the line x is equal to 2. Your graph is symmetric with respect to the line x is equal to 2. Okay, so which one is true here? So okay, So let's draw the some situation here. Okay, so let's say this is your y-axis, okay, and this one is your x-axis. Clear? This is x-axis, y-axis, and this is x-axis. Got it? Now, graph of fx is what? Symmetric about line x is equal to 2. So x is equal to 2 is somewhere here. That is what? That is x is equal to 2. Yes or no? Y-axis is what? Y-axis is x is equal to 0. So x is equal to 2 is parallel to this. Now your graph is symmetric. So symmetric means, let us assume the graph is like this. Let's say graph is like this, or let's say this kind of graph. Okay. So similarly, if this is symmetric with respect to this line, so graph on the opposite side means left hand side of x is equal to 2 is the similar to same as this. Okay. Meaning is what? Meaning is, if you choose any x, any point at some distance, let's say at x distance, if you choose some point, so that point is what? That point is 2 here, and x is this, so you can say x plus 2. Okay. So if the value of this function at x plus 2 is some here, so you have the same value at x distance on the left hand side because your graph is symmetric. So x distance, if you take another point at x distance, so that is what? That is, this whole distance is 2. Yes, this is x. So this point is what? This point is 2 minus x. Yes, 2 minus x. Yes or no? This is 2. Sorry. This distance is 2. This is x. So remaining is what? Remaining is 2 minus x. So sir, at that point, the value is same. Value of function is same because function is symmetric with respect to x is equal to 2. So you can say value of function at x plus 2 is same as value of function at 2 minus x. Okay, so this is what? This is the final answer. So f of 2 plus x, you can say x plus 2 can be written as 2 plus x. So f of 2 plus x is equal to f of 2 minus x. So option B is what? That's the correct one. Okay, 2 plus x and 2 minus x function have the same value. Okay, so B is what? B is the correct option here. Okay, so everyone, this is your assignment number 1. Okay, in the next video we'll discuss the next assignment. Till then, bye bye everyone, and thank you.